Hello, and welcome back to Clarkenomics. This video is about marginal trade-offs. So to start things off, we're going to start with a non-marginal trade-off just to draw the distinction a little bit better. So imagine, if you will, that it is summer and you want to run a cold drink stand in your neighborhood. People are hot, they need to cool down, you need money, everybody's happy. And you're trying to decide what to sell. You're going to sell only one of two alternatives. And those alternatives are lemonade, and limeade, which is a real thing. Not super common compared to lemonade, but it is, in fact, a drink. So let's say, with this trade-off situation, one or the other, two alternatives, costs and benefits and advantages and disadvantages, blah, 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 that you decide to choose lemonade. So using the terminology we've already established, lemonade would be your choice, and limeade would become the opportunity cost of that trade-off. But then you decide, okay, I would like to make a more marginal decision because I've seen some of these videos and I've changed my way of thinking. You hear that people like both of these, lemonade and limeade, and so you decide to sell what the people want, lemonade and limeade. But the question becomes a marginal question. You wonder, okay, I'm going to sell both, but how much of each drink should I produce? Because you can't make infinite amounts of these drinks, nor would you want to. Now, the good thing is these drinks share a few ingredients, right? They're each made from a fruit, sugar, water. But the question you have to answer is, how should you allocate your sugar and water, right? Allocate just means to distribute. How should you divvy up? So do you allocate your sugar and water more towards the production of lemonade or more towards the production of limeade? And of course, there are tons of different combinations of lemonade and limeade you could produce, but we're going to boil it down here to 6. Options A, B, C, D, E, and F. So take a look at option A. Option A, you're producing 10 gallons of lemonade, but because you've used all of your resources to produce lemonade, you don't have any left over for the production of limeade. So if you produce option A, you are only producing lemonade, no limeade. If you produce option B, well, you're only producing 8 gallons of lemonade, which frees up enough resources to produce 1 gallon of limeade. Now, why are these numbers a little different than each other? It could be that, in this example, limes are more tart and you need more sugar to balance things out. It doesn't really matter. I made the numbers different from each other so that we can do some interesting stuff with opportunity cost down the road. Like this. So let's calculate an actual opportunity cost here. Imagine that at first you decide to produce option A. Again, that is 10 gallons of lemonade, 0 gallons of limeade. But then you decide to pull a complete 180 and to produce option F. For option F, you are not producing any lemonade at all, and you're only producing limeade. And if you do that, you can make 5 gallons of limeade. So just like any trade-off, this is going to have a choice and an opportunity cost. The choice here is clearly 5 gallons of limeade, right? That's what you chose. You decided to switch from A to F, which means you're now producing 5 gallons of limeade. That's what you're getting. But what you have to give up in order to do that is you have to have an opportunity cost here. You have to give up 10 gallons of lemonade. Because at option A, you are producing 10. At option F, you're producing 0. Now, again, you're getting 5 more gallons of limeade. That's your choice. But the opportunity cost, what you gave up, is 10 gallons of lemonade. So opportunity cost is always the thing that you give up. And because we have numbers here, we can quantify it. We can come up with some amounts. So we're going to do a little bit of practice here. There we go. All right. So what's the opportunity cost of deciding to move from option A to option E? You can pause the video if you want to, try to work it out, and then unpause it because I'm going to tell you the answer in 3, 2, 1. The answer is 8 gallons of lemonade. So at option A, you were deciding to produce 10 gallons of lemonade, no limeade. You switch to option E, you're producing 2 gallons of lemonade and 4 gallons of limeade. So you're choosing the choice of producing 4 more gallons of limeade than you were. But if you do that, you're going to have to give up 8 gallons of lemonade. Okay, let's do another one. Option F to option A. Pause it if you want to, because I'm going to give you the answer in 3, 2, 1, now. The answer is 5 gallons of limeade. So, when you were producing option F, you weren't producing any lemonade, 5 gallons of limeade. If you switch to option A, you're getting 10 more gallons of lemonade than you were before, but in order to do that, you're going to have to give up those 5 gallons of limeade. So the opportunity cost, always what you give up, is 5 gallons of limeade. So in other words, whichever number goes down from what it was, that's going to be your opportunity cost. Okay, 2 more. Option D to option C. Pause it if you want. Here comes the answer in 3, 2, 1. 1 gallon of limeade. And lastly, option B to option D. Pause it if you want, because here comes the answer in 3, 2, 1. 4 gallons of lemonade. So that is how you calculate opportunity cost based off of a table like this one. Eventually, we're going to see this in graph form, but for now, the information is organized very neatly in the table, which allows us the opportunity to get interesting here. So instead of looking at the opportunity cost of moving from a production option to another production option, we can try to calculate the opportunity cost of, for instance, producing 1 gallon of limeade. So for every gallon of limeade that you produce, how much lemonade do you have to give up? That's the question that we're asking here. And we can use the table to help us a little bit, because here we weren't producing any, right? And if we produce 1 gallon of limeade, how much does our lemonade production go down by? Well, that's pretty clear. That goes down by 2 gallons, from 10 now down to 8. And to put that, clearly again, to produce 1 more gallon of limeade, you have to produce 2 less gallons of lemonade every time, right? Because every time you increase limeade production by 1 more gallon, you're decreasing lemonade production by 2 gallons. So it's a 2-to-1 ratio. Okay, the real tough question. What is the opportunity cost of producing 1 gallon of lemonade? And this is tricky because lemonade moves by increments of 2 here, not 1. But the principle still applies. So the answer to this question is to produce 1 gallon of lemonade, you need to give up a half a gallon of limeade. That's the opportunity cost of every gallon of lemonade. And so, if, in other words, you have to give up, um, if you have to give up 1 gallon of limeade for every 2 gallons of lemonade, then you only have to give up a half a gallon of limeade for every 1 gallon of lemonade. So if you could picture it here in between, you would have like the number 1 and the number 4.5 right there. So that's how that goes. Opportunity cost is all about ratios. And you'll get more practice with this, and we'll apply these concepts later. But to quantify opportunity cost is a very important idea because it helps us make better decisions by looking at what we're giving up and being able to compare it to other things. So that's the idea of marginal trade-offs. Thank you for watching.